Known as, I forgot where I put my black pen, distributive property. We're going to be multiplying polynomials, but we're going to start by multiplying a polynomial by a monomial or a constant. A couple things that we have to remember and talk about as we go through, but I'm just going to start refresh your memory with the distributive property. Here's the nice thing about the distributive property, and you should love it. The distributive property is a rule breaker. Breaks all the rules. If you think about what's happening with the distributive property, if I gave you a situation like this and said solve that, what you should do is you should realize, hey, according to my order of operations, I have to complete what's inside of the parentheses or the groupings first. That is my very first step. So if I was solving this, really what I should do is I should take that 6 plus 4, get my 10, then since there's only the multiplication left, that means that's my last step or my next step, and 3 times 10 of course is 30. The distributive property comes along and says, psst, I don't listen to your rules. I don't. Distributive property says, here's what I'm going to do. Instead of doing my grouping first, I'm going to do my multiplication first. So it says, let's go ahead and do that. And we can do that as long as we distribute, which means take that 3 and multiply everything in there. Of course, 3 times 6 is 18, and 3 times 4 is 12. Now you can go back and add, and you get 18 plus 12, which is 30. So either way, you wind up with the same solution. So that's what the distributive property is. It allows you to get around that, do the work inside the grouping first before you multiply. Only works right now for multiplication. So that's what it is. It's a rule breaker, law breaker. So what we're going to do is we're going to use that to our advantage to simplify expressions we normally could not. So if I gave you something like 4 times 2x minus 3, let's start there. Normally we would look at that and say, hey, you got to follow your order of operations, but in this case, I can't take 2x minus 3. I can't take 2x minus 3 because I don't know what x is, so I can't actually perform that subtraction. So what I'm going to do is say, no fear, got my little buddy the rule breaker. I'm going to distribute this 4 first. So I'm going to distribute that 4 in there. 4 times 2x, of course, is 8x. And then minus 4 times 3, of course, is 12. So now I have a more simplified version of what I had before. I still can't combine the 8x and 12 because I know what the x is, but I've now gotten rid of the grouping and I have a much simpler expression to work with. Let's try another one. Let's throw in a trinomial. So we're going to take, let's do negative 7 times 3x squared minus 2x plus 1. So again, according to our order of operations, we technically should do all this work inside here first because it's in a grouping. But I cannot do that because, well, I don't know what x is. So I'm going to break that rule by distributing my negative 7. So I'm going to come up here and I'm going to say, all right, I can do my multiplication first as long as I distribute it to everything in there. So I'm going to go ahead and distribute that. Negative 7 times that 3x squared is negative 21x squared. Negative 7 times that negative 2x is positive or plus 14x. And negative 7 times 1, of course, is negative 7. Easy peasy. And of course, if everything started in standard form, it would wind up in standard form and I don't have to worry about it, but always double check, make sure it's still in standard form. And we are 2, 1, 0, according to degree, we're good to go. Now, before I go to the next part, I'm going to refresh your memory about something. And that is some exponent rules. Exponent rules. If you were multiplying things with exponents, you will get the resultant by adding the exponent. And I believe probably the property you saw at some point was a to the n power plus a to the m power is equal to a to the n plus m power. That is your exponent rule for when you are, I apologize, I just screwed up my exponent rule. That is multiplication. A to the m power times a to the m power will give you a to the n plus m power. All that means is when you're multiplying like bases with exponents, you can get the resultant by just putting the base down and getting that exponent. And let's take it to something with actual numbers. If I have x to the third and I'm multiplying that times x to the second, that means that my resultant is x to the fifth. Should have learned that in Algebra 1A. Hopefully that's pretty simple. If not, you can practice that before you move on to this. Reason I say that is because we may have to distribute something that has a variable with it. So let's take 2x and let's distribute that into 4x minus 3. We'll start fairly simple. So I'm taking this 2x and I'm multiplying it times that linear binomial inside. So I'm going to take the 2x times the 4x and the 2x times that minus 3. Now, this is where a lot of students run into some trouble. Keep in mind that when you're dealing with these x's, just like we talked about back in Objective 1, this guy has a power of 1, this guy has a power of 1. So when we distribute that, 2x times 4x, of course, is going to give me 8x, but when I add those exponents together, 1 plus 1, it is 8x squared. And you should know that because if I'm taking 2x times 4x, this is all multiplication, so it's really 2 times x times 4 times x in the long run, which we can rewrite as 2 times 4 times x times x. And of course, 2 times 4 is 8, and x times x is x squared. So we can expand that out and go through all that if you want, but I'm hoping you can go straight from 2x times 4x is 8x squared, but you can follow that progression if you need to. Then, of course, follow along. 2x times this minus 3 or negative 3 becomes minus or negative 6x. Hopefully that's okay. Let's step it up another notch. This time, let's take something like 3a squared, and let's multiply that times a to the third minus 4a squared plus a minus 2. So we have a really large polynomial inside of this grouping, and we have a 3a squared that we're going to multiply. Once again, I cannot combine all this stuff in the grouping because I don't know what a is. So I'm going to get around that by using my rule breaker, the distributive property, and I'm going to distribute, whoops, I almost used the wrong color. Let's grab some blue here, change it up. So I'm going to distribute this 3a squared into everything there. A couple things that we might want to take note of before we actually distribute. This a here, he not only has a coefficient of 1, he also has a power of 1. So that's important to know that. You do not have to write that in, but you should be aware of that. So 3a squared times a cubed. This guy also has a coefficient of 1. So 3 times 1 is 3. A squared times a to the third, once I add those exponents together, gives me a to the fifth. Then I'm going to keep marching on. 3a squared times this negative 4a squared becomes negative 12a to the fourth. 3a squared times this 1a becomes plus 3a cubed. Don't forget we're adding the exponents. This is a 2 and a 1. Then 3a squared times that negative 2 becomes negative 6a squared. Seems a little difficult, right? It's not that bad. Make sure you keep in mind what all your coefficients are, what all your exponents are, and that when you multiply, we simply multiply the coefficients as normal. We add the exponents of the variables. One of the things I did not mention, I'm hoping I don't need to, but I'll talk about it right now. This guy technically has that a to the 0 power in there. Don't forget that. So when I take the a squared times a to the 0, that technically becomes a to the 2 plus 0 power, which is still just second. I don't know if you have to go through that, but it's probably worth a mention. I'm going to put another one up here. Let's have you pause the video. Let's have you try it. Then you can come back and check your work. So let's take negative 2y, and let's distribute that into y cubed minus 4y squared plus y, yeah, that's fine, plus 7. So go ahead, pause the video, give it a whirl. Let's see how you did. So first thing, I'm going to distribute this negative 2y into here. You should know we're doing that by now. Can't do the work inside of the grouping. The other thing I'm going to do, I don't know if you did it or not. You can, you don't have to. So I'm going to keep in mind this is a coefficient of 1. This guy's also a coefficient of 1. And this guy has an exponent of 1. So there's important things to note. They don't have to be written down, but you should note them. So I'm going to distribute this negative 2y in here. Negative 2y times 1y to the third. That becomes negative 2. This guy also is a y to the first power, so that when I multiply them and add those exponents together, I'm going to wind up with y to the fourth. I'm then going to go ahead and distribute the negative 2y into the negative 4y squared. That becomes positive 8y cubed. I'm going to take the negative 2y times that 1y. That becomes negative 2. And y to the first times y to the first is y squared. And last but not least is negative 2y times that 7. That just becomes negative 14y. Final answer, fourth degree, 4-term polynomial. Hopefully that made sense. If you have any problems, we'll clean up in class. See you later.